Welcome to the third tutorial. In this tutorial, we will see the graphics package of MATLAB. It is often said that a picture is worth 1,000 words, or in our case, it is better than a huge matrix of numbers. But the picture needs to be illustrated properly. Out of many options that MATLAB provides for graphing, the simplest for 2D plotting is the command plot. We just have to provide two vectors of equal length and MATLAB will plot one versus the other. The resulting plot can be and should be improved so that it can be easily interpreted. Let's say we have to plot two functions, for example cos x and sin x in the same axis. So let's write a script for that. Let's name our script plot 2D. We will now define our domain or the independent coordinate x to be linspace 0 to 2 pi in 400 divisions, and let's store sin x in y1. Now to plot sin x, we will just write plot x comma y1. Let's save the file and run. So as you can see here, MATLAB has plotted sin x up to 2 pi. Now if we want to plot cos x in the same axis, we need to use hold on. This hold on command will tell MATLAB to retain the previous plot while plotting a new graph in the same axis. Let's try it. Y2 will store cos x and we will use hold on plot x comma y2. Again save and let's plot it. As you can see, MATLAB has plotted the two figures in the same axis. If we miss this hold on, MATLAB will replace the previous figure with the latest one. We will then pause our script for 3 seconds to see what is happening. Let's save the program and run. As you can see here, MATLAB first plots y1, then replaces y1 with y2 as we missed the hold on. So when plotting two or more graphs in the same axis, we should use hold on. Let's run our code again. As you can see, these plots look too plain. So let's improve our plots. First, we will see how to edit the plots using figure editor. Let's do it in stages. First, we will label the axis, give title to our plot, indicate which is cos and which is sin. So for that, let's maximize the figure and go to edit plot. Double click on axis and now we have to mention x label. Our x-axis represents theta in radians, so let's display theta, Greek symbol theta instead of writing theta, and the units are radians, and then y-axis is sin x and cos x. We can insert title from here also. Title for our plot is sample plots in MATLAB. Now to indicate which curve is sine and which is cos, we can use legend. We go to insert and insert legend. So it will give me an identifier to indicate which data represents cos and which data represents sine. So here we double click it and the blue line represents sine and the other line represents cos. So this is how the plot will look like after we improve it in the first stage. In the next stage, we will change the appearance of the graph so as to differentiate the two graphs easily. Here both the graphs are represented by continuous lines. So let's change the line style of one of them to dashed. So let's again go to the figure editor. Here you can see line which represents the line style. Here we will select dash and then as you can see the appearance of cosine has changed from continuous to dash and so is the entry updated in the legend. Now let's add some finishing touches to the graph so that it can be presented in a nice way and can be easily read. For that we can increase the line width. Let's say as you can see here the line width is 0.5. So let's make it 1.1. Let's make it 1.2. Let's change the color from red to black. And let's change this color to blue. Let's increase the font size of this axis so that it can be easily read. So we can do that here. Select the Y label, change the font to say monospaced and we can increase the font size. Similarly with x-axis. And title. As you can see, we have improved the appearance of the plots and now we can save them. Before saving, let's improve the resolution of the plots. So that we do that by going to File, Export, Setup. We go to Rendering, to Resolution. Let's set it to 300 and we apply it to figure. And OK. Now if we can save our figure. Sample plot 1 and save. As you can see that plot figure has appeared in the current folder. So if we want to edit that plot further, we can just open this fig file and continue editing. So let's do it. We can double click on it to open and Suppose I want to mention the identifier sine and cos near the curves and not in legend. So first let's hide the legend. Then we go to insert, text box. Let's say we will enter sine first. Sine x. Let's edit it. So we go to text box, we select the line style as none, alignment center, we'll change the font and the font size. Similarly, we can do it for cos x. Every time we run a MATLAB script using plot, MATLAB will give us a plain figure and we will have to go through the entire process each and every time. So there's a way by which we can edit the plot directly from the script. We can do that using handles. When we want to edit a particular line in figure, we should be able to tell MATLAB to edit that particular line and not any other. So how do we do this? We will use something called handle. Handle creates a reference for that particular object. We can access the properties of that object using its handle. So how do we use it? Let's edit our previous plots using handles. So P1 will serve as the handle to the plot Y1. Let's see what P1 stores. Let's comment this, save and run. These are all the properties of Y1 that we can access through P1. Let's plot Y2 and edit our plots step by step from the script. So P2 will store handles to plot Y2. So now we will label our x-axis, y-axis and give our figure a title. To label x-axis, we write x label theta in bracket radians. Y label it's sin x and cos x. For title, we say sample plots in MATLAB. Then we can even add legend from here. Legend sin x, since we are plotting sin x first, then cos x, and that should do it. So as you can see here, our plot has a legend which we can move around. It has a title and it's a typo. It has X label, it has Y label. Let's correct. Now we will go to the next step where we change the appearance of the two graphs. So to change line width of P1, the syntax is P1 dot line width. Let's set it 1.2. Let's change the color also. So P1 dot color. Let's make it black. The Shortcut for black is K in MATLAB. Let's make P2 a dashed line, line style, dash. Let's change color of P2 to magenta M, and now line width P2 dot line width is 1.2. So let's run it. So as you can see, we have again improved the appearance. The continuous line represents sine and the dotted line represents cos. Now we would like to have our x-axis to be in terms of multiples of pi instead of integers. So let's see how to do it. Let's close the figure. For that, we will get the handles to the current axis by GCA. GCA will give me get current axis. Now X has handles to GCA. Now we want our X labels to appear at the following positions. So X dot X tick, we want 0, then we want pi by 2, then we want pi, now let's save and run the code, and let's see how our x-axis looks. As you can see, MATLAB has printed the fraction values of pi, pi by 2 and all. Instead of that, we want MATLAB to show Greek symbol pi and its multiples. To tell MATLAB that, we have to create something called a cell array. We will say X tick label to be, we have to enclose that in curly brackets, and we have to give the input as strings. So 0, then pi by 2, then pi, saving the program, and let's run it. Oh, we missed the X here. So save the program and run it. As you can see, MATLAB has replaced the fraction values by the symbol pi. We can improve it further by increasing the font size. Let's say X dot font size equal to 12, or let's say 14. So as you can see, MATLAB has made those changes. We can eliminate this white space by setting the limit to x-axis. To set limit to axis, we say axis parenthesis, we have to give the limits as a vector, and the syntax is x minimum, which is 0, then x maximum, which is 2 pi, then y minimum, which is -1, and y maximum, which is 1. So we will again run the code and see. So now it looks better. One more thing which we can do is we can remove this legend and put identifiers close to the curve as we did previously. For that we will use a function called gtext. So let's comment our legend, and so g1 will store the handle to gtext sin x, and g2 is gtext cos x. Let's set the property font size to be 13. Same with g2. Let's save the program and run it. So what this g2 will do is that it will give me a crosshair with which I can place the text wherever I like. So first is sin x, so let's put this text here. Next it will ask for cos x, let's put it here. Let's add some markers on the sign. To display markers over the plot, we write, let's comment gtext again and uncomment legend. So now to marker, we write p1 dot marker as circle. There are so many different types of markers which you can look in the MATLAB documentation. Here we will use a circle. So let's see. So as you can see, the plot is covered with circles. This is due to the fact that our vector is of size 1 cross 400. But we don't want these many markers. We want a certain gap between two markers. Let's say they appear after every 19 elements in X. So we will define a vector gap and it starts from 1 with increment of 19 up to the length of vector x. Now we don't want to plot the entire y1 vector. We just want to plot the selected elements in y1, and that selection is governed by the vector gap. So we will just plot elements in y1 which corresponds to the values in gap. Then we will say our marker is a circle, and let's change the marker to continuous, and this time let's make cos as dashed line. Let's save the file and run. Looks pretty, right? Figures in MATLAB actually go a long way. They represent your results in presentations, reports, etc. So, presenting a figure in a better way is as important as plotting the figure. The job does not end with plot, but we must spend some time and effort in enhancing them so that a third person can interpret and understand them easily. So we just saw the 2D plotting option available in MATLAB. We will now see surface plots. For that, we will take example of plotting the mode shape of plates. Let us first see the geometry of the plate. This is our plate ABCD, which is simply supported on all the four sides. The mode shape is given by multiplication of two sine functions, one along the x direction and one along the y direction. To plot surface, we will need the values of w over the area of the plate. The strategy which we will follow for this is, first we will create two vectors along x and y. We already have a file saved. Let's look at that. So this script will plot mode shapes of a simply supported plate using surf. So first we define the length of the plate and the width of the plate. This is the length and this is the width. Then we set the mode shape number m and n. After that we create two vectors x and y as the first step in our strategy. X is discretized from 0 to a in 400 parts. Similarly, y is discretized from 0 to b into 400 parts. We will now create a grid or mesh over the plate using mesh grid. What does that? Suppose I have these two vectors. Let's say this is x and this is y and this is the plate. So if I am using mesh grid, it will create two matrices. One will contain rows of x and other will contain columns of y, so that if we use array multiplication, we will get each and every point in that domain. Let's see an example. So suppose I have a vector x which goes from 1 to 3 and y goes from 4, 5 and 6. Now if I use mesh grid, let's store the x matrix in capital X and column matrix in capital Y and mesh grid x, y. So as you can see, x contains rows of x and y contains columns. And if I do an array multiplication, what I will get is each point in this matrix. Let's get back to our editor. X1 contains the information about the mode shape in x direction and y1 contains the information about the mode shapes in the y direction. To obtain z, we use array multiplication. Let's save the program and let's run it. So we got a plot, but it's completely dark. This is due to the fact that we have a very fine grid. You remember our x and y are 400 and 400. So z is of size 400 cross 400. That's why to see the actual plot, we will set the line style to none. So the handle to surface is s1 dot line style which we will set to none. Let's save it and run it. So as you can see here, according to the displacement of each point, MATLAB has colored the plot. We can add our usual information regarding X label, Y label and Z label. So X is the length, Y is the width, and the Z direction represents the transverse displacement. And let's change our N to 2 and let's see what happens. So as you can see, we get a figure in which along the x-axis we have a behavior like sine 2 pi x by a, and along y-axis along the width where m is 1 we have a behavior similar to sine pi x by a. So now if we want to print our title, and the title should show what is the value of n and what is the value of m. So for that we will use this new function sprintf. Sprintf will create a string which we can use as a title. Similar to printf, if you remember, where we used the format specification %d for integers, here also we will use %d and %d to input the values of n and m at particular locations in the string. So currently our n is 2 and m is 1. So we create a string and store it in t1. Then we tell MATLAB to use this t1 as the title. If you see this figure, it's an isometric view. Suppose I want to look it from the top view. For that we use the command view2. View2 will tell MATLAB to display the surface plot in a top view. So let's see how it looks like. In this way it is much more clear that along length side I have behavior like sine 2 pi and n is 2, and along width behavior is like sine pi x by b and m is 1. We can change m to 2 and let's run it again. In this case you can see MATLAB has plotted the figure and title with necessary changes. Now we will move on to contour plot. So what it does is it plots locus of points which are at the same value of z, that is they have same height from the base. If we look at our 1-1 mode shape, we can observe that certain points can be connected by a curve and those points are at the same transverse displacement. So in order to see it in forms of lines, we will replace surf with a contour. So C1 will be the handle, contour x, y, z, and let's save the figure. Let's save the file, close the figure, and let's run it. So as you can see, MATLAB has given me a locus of points which are at the same distance from the base or which have the same transverse displacement. Now if we want to view the surface plot and contour plot side by side in the same window but in different axes, we can use subplot. So let's see how to use it. Let's uncomment surf. To tell MATLAB we are using subplot, we begin with writing subplot Now this M and M, these first two numbers indicate the size of the matrix. So in this case we have two figures and we can either place them side by side in one line or vertically one below the other. So either we can have a matrix of size 1 cross 2, that is one row and two columns, or two rows and one column. So let's place them side by side. For that we will tell MATLAB the size is one row, two column, and the first figure will be the surf, and the next figure, again we had to mention subplot, the next figure in that 1 by 2 matrix will be contour. You can adjust the size of the figure for better viewing. We have seen 2D plotting option, plot. We have seen 3D plotting option or surface plotting option, surf, contour. We have seen how to edit the plots from the figure window using figure editor. Then we have edited the same figure using handles from the script. Then we also have seen how to use subplot. There are two more interesting plotting options. One is quiver, other one is stem. I would request you to search for quiver plots and stem plots in MATLAB help. Here we conclude our tutorial for plots. In the next tutorial, we will see about loops, vectorization, and finally animation. Thank you.